morning to everyone. What we are going to do today is to know about the basic concepts of mathematics. We are going to discuss about the first year mathematics part. I am going to take up the portion which comes under unit 3. We call it as application of differential calculus. Application of differential calculus. First, the basic part we can make it out is a constant. A constant is the one which does not change. The next what we have is variable. Variable which changes frequently. We denote them by x or y or z or s or t with small alphabets. This is what we call it as variable. We will go in for the expression. The expression, the constant, the variable related by arithmetic operators. We make them as expression. So the expression we can call it as say 4x, 6y, 7z, or otherwise 7x square, 6y cubed, 5z power 10. We call them as an expression. This expression, when we equate it to a constant or a variable or another expression, we take it out as an equation. Example, 4x, 6y, 7z equal to 0 or equal to one constant 100, or we can make it out as another expression. We call it as an equation. Now from the equation we go into the and discuss about inequality. Less than, greater than, less than or equal to, greater than or equal to. We say greater than or equal to. This is simply less than. This is greater than. And also not equal. All these come under inequality. Instead of equal to sign, if we place any of this, this becomes an inequality. For example, we can have 4x, 7y less than 100. Or we can say 5x minus 7z greater than or equal to 200. These represent inequalities. Next, we enter into the x-axis and also the y-axis part of it, which you know already in your smaller classes. We usually represent this as coordinate system. We call this as x-axis, call this as y-axis. This is supposed to be our origin. In this coordinate system, suppose I have a curve. I have a fixed point P, another point Q. When I travel from Q to P, I can make out a tangent. This tangent touches the point P and makes an angle psi with the x-axis. When we are discussing about this angle, the tangent of psi becomes our slope. Now this slope gets us the tangent of a line of the line PQ. When the line occurs in Q, let us say this line, we call it as either a chord or we call it as a secant. We call it as a secant. This tan psi or the slope or the tangent of the line PQ, we make it out as dy by dx, or otherwise we call it as rate of change. Rate of change. Now this rate of change helps us in many different fields. Maybe in mathematics to find the maximum or minimum, in economics to find the maximum or minimum, to decide about either to maximize it or minimize it. All these depending only on rate of change. Now this rate of change, when I go to find the next differential, I say dy by dx is now rate of change of y with respect to x. When I go for the successive differential, then I will be having d square y by dx square. When I equate dy by dx to 0, I get different values for x. Let us say alpha and beta. When I substitute x is equal to alpha in my d square y by dx square, and I get d square y by dx square is greater than 0, then I say that y is minimum. That means whatever the function which I have taken is a minimum function when I substitute x is equal to alpha. Suppose let us say x is equal to beta, I get my d square y by dx square, I get my result less than 0, then I decide y is maximum. When I substitute the value of x alpha or the value x is equal to beta in my function y, then I get the maximum value or the minimum value. The maximum value or the minimum value. So the rate of change of one quantity with respect to another quantity gives us the slope which decides about the maximum or the minimum part. Now this rate of change comes into our application of differential equation, differential calculus, in such a way that it gives us the curvature. When I go for the definition of curvature, the curvature is nothing but the rate of bending. Now what is the meaning of rate of bending? When I have a curve goes like this, the turning at this particular place depends on my center of gravity. I get a particular point. Having this point as a center, I can draw a circle. I can draw up a circle. Now this circle is the circle of curvature. the circle of curvature. The radius that we have is the radius of curvature. The point, we define it as x bar, y bar. We call them as centers of curvature. So now this curvature, when we have all these points together, this radius is fixed. Taking into account the center of gravity, nobody falls down when they have a bend over. So that gets me what is the rate of bending, and it is denoted as K. So the rate of bending is the curvature and it is denoted as K. With that reference, we enter into the radius of curvature. Now the radius of curvature is the reciprocal of the curvature. The reciprocal of the curvature. What is meant by reciprocal of curvature? That is what we have, rho is equal to 1 by K, or otherwise we can say K is equal to 1 by rho, or otherwise we can say K is equal to 1 by rho. So that rate of change of one quantity with respect to another quantity, we call it as dy by dx. That is your slope. Coming to the next, with reference to this, the rate of bending of curve is what we call it as the curvature. The curvature, we denote it as K. From K, we go into what is meant by radius of curvature. Now the radius of curvature is nothing but your reciprocal of curvature. We make it out as rho is equal to 1 by K. So that is K is equal to 1 by rho. So once we have the rate of change, immediately we go into the rate of bending. Then we can go into the circle of curvature. We can go into the radius of curvature, and we can find out through what we cannot fall, or the vehicles will not toggle, or we can make use of any of the practical problems using our curvature and the rate of bending. As a result of this, we go in for calculation of radius of curvature. Now the calculation of radius of curvature gives you the formula radius of curvature in our x and y coordinates system. We do have it as 1 plus dy by dx the whole square, the whole raised to the power 3 by 2 by d square y by dx square. So that means it is necessary that we have to go and find dy by dx. It is necessary to go and find out d square y by dx square. So the simple differentials, very simple basic differentials which we have studied in our plus 2 classes will be necessary to find out our rho calculation. If the same rho, when I get d square y by dx square 0, this becomes infinite. Infinite value which I cannot take it up because I may not get my continuity, or I will not get my continuity. So my formula changes according to the other way around. 1 plus dx by dy the whole square divided by whole power 3 by 2 divided by d square x by dy square. D square x by dy square. Now if I have the denominator 0, I can do my differential in the other way around and then simplify to get my radius of curvature rho. Now this radius of curvature again can be calculated for parametric representation also. Now the parametric representation, how it comes? In parametric form, we have one parameter discussed, or anything we can take it. The parameter, we usually take it in the form of theta or t. Either theta or t we take it for the parameter. In that case, the rho becomes x dot square plus y dot square, the whole raised to the power 3 by 2 by x dot y2 dot minus y dot x2 dot. What is the meaning of x dot? Now x dot will become dx by d theta. If I take up my parameter to be d theta, y dot is my dy by d theta. If I take my parameter to be theta, now my d square x by d theta square becomes my x2 dot, and d square y by d theta square becomes my y2 dot. Accordingly, I go to find out my radius of curvature. Once I go to find out my radius of curvature, then it will be easy for me to proceed for finding center of curvature and also the circle of curvature. Now let us take one small problem. Say that what is the radius of curvature? Radius of curvature of the circle with equation x minus 3 the whole square plus y plus 4 the whole square is equal to 16. The question is, what is the radius of curvature? Now the radius of curvature is the only one which is necessary there. So radius of curvature, it is a circle. The center with 3 minus 4. The radius is 4. So the radius of curvature rho is the same as the radius of the circle R. That becomes 4. Now if I am asked the question what is the radius of curvature of a circle with equation this, then I have the circle rho equal to R equal to 4. Suppose I am asking a question like what is the curvature? Now curvature becomes automatically 1 by 4. Curvature automatically it becomes 1 by 4. So this is how we go to check or find in part A questions to find out what is either radius of curvature or as its curvature. So curvature becomes your rate of bending. Radius of curvature is the reciprocal of the curvature. Any circle whose radius is there given,